Welcome back to the deep dive. We have a very specific target on our radar today. We are decoding the 1Y0-342.
The NetScaler exam.
Exactly. And looking at the documentation you sent over, this isn't just a vocabulary test. This thing looks like a beast. We're talking about a 75-minute timer, 60 to 70 questions, and a passing score of 65%. That actually sounds, I don't know, deceptively low.
It does.
Like, 65 doesn't sound hard until you see the questions.
That's the trap. It sounds achievable, but the margin for error is, well, it's razor thin because of the complexity. You aren't just defining terms.
Right.
You're dealing with scenarios, performance-based items, and, specific architectural logic. If you don't know why a feature works the way it does, you're going to struggle to hit that number.
So our mission today isn't to just rattle off an answer key. It's to get under the hood. We're going to look at a stack of practice questions specifically around visibility, security, and advanced logic, and sort of figure out the thinking process.
Exactly. We want to decode the logic so that no matter how they phrase the question on exam day, you know where to look.
All right. Let's start with something that keeps every IT admin up at night. Visibility. Or rather, the lack of it.
A classic why is the network slow problem.
Right. So let's look at this first scenario from the prep material. You're the admin, you have a web application, and the tickets are just piling up. Users are screaming about high latency. The boss is hovering. You need to know right now, is it the network? Is it the server? Is it the user's ancient laptop?
The blame game scenario. Yep.
The exam gives you 4 tools to choose from: Security Insight, Web Insight, Video Insight, or HDX Insight. Which one is the weapon of choice here?
So if you rush, you might just grab HDX Insight because, Citrix and HDX, they usually go hand in hand. But that would be a mistake.
Okay.
The answer here is Web Insight.
Okay, hold on. Why not HDX Insight? I feel like I hear HDX constantly when people talk about NetScaler.
You do, but context is king. HDX Insight is fantastic, but it is specifically engineered for Citrix virtual apps and desktops, traffic, what we call the ICA protocol.
Oh.
If the question was about a virtual desktop freezing up, HDX Insight is absolutely your answer. But the scenario specifically mentioned a web application.
So we're talking standard browser traffic, HTTP.
Precisely. Web Insight is the analytics engine built for that layer. It doesn't just tell you it's slow. It breaks that latency down into segments.
Okay.
It shows you the client-side latency, the server processing time, and the network transit time.
So it actually lets you say, hey, it's not our server, it's the user's internet connection.
Exactly. It visualizes the entire request-response chain. That distinction matching the analytics tool to the specific protocol, that's a recurring theme in this exam.
Got it.
If you see web app, you think Web Insight. If you see virtual desktop, you think HDX Insight.
Okay, so Web Insight for web apps, simple enough. But let's say the problem isn't performance. Let's say the problem is human error.
My favorite kind of error.
This leads to question 7 in our stack. The system is acting weird. A setting has clearly drifted, and you suspect someone on the team, fixed something they shouldn't have. You need to find the culprit. The exam asks, which feature allows an admin to see who changed a configuration?
Right. And the options usually throw people off here because they sound similar. You've got performance monitoring, license management, traffic capture, and configuration audit.
Traffic capture sounds promising. Doesn't that see everything?
It sees the packets, it sees the data flowing through the pipes, but it doesn't care about the admin console.
Ah!
If you want to who clicked the button, you need configuration audit.
So this is the internal black box recorder.
It is. Configuration audit is distinct because it tracks the management plane, not the data plane. It logs the who, the what, and the when. If Bob changed the load balancing method at 2:00 p.m. and the site crashed at 2:01 p.m.
Sorry, Bob.
Configuration audit is how you find Bob. And beyond just troubleshooting, think about compliance. If you're in a regulated industry, finance, healthcare, you legally need that audit trail.
Good point.
The exam expects you to know that distinction. It's not about monitoring the traffic. It's about monitoring the configuration itself.
Okay, sticking with the theme of management, let's talk about the console itself. This is question 4. The question asks about the primary requirement for managing a NetScaler instance via the console, what we used to call MAS.
Right, the management and analytics system.
The options are creative. One is use a dedicated physical cable. Another is disable the local firewall. But the correct answer is ostensibly the simplest one. Add the instance to the console inventory.
It sounds too simple, doesn't it? Like a trick question.
It does. I'd be looking for the complicated technical hurdle.
But the logic holds up. I mean, the console is a centralized management server. It can't manage, monitor, or push configs to a device it doesn't know exists.
Right.
You don't need to rip out firewalls. That would be a terrible security practice, by the way. And you don't need special cables in a cloud-centric world.
You just need to introduce them.
Exactly. It's an inventory management step.
Yeah.
Step 1 is onboard the device. Until it's in the inventory, the console is blind to it. It's a prerequisite question. Before you can do the fancy stuff, you have to do the basic stuff.
So don't overthink it. Sometimes the answer is just plug it in, digitally speaking.
You're correct.
All right, let's shift gears. We've covered visibility and management. Now I want to move to segment 2, security architecture. Because looking at the source material, the web app firewall, the WWave, seems to take up a huge chunk of the brain space for this exam.
It's a massive topic. A NetScaler is a security device as much as it is a load balancer.
And there's one concept here that seems to trip everyone up. It's the difference between a profile and a policy. Question 2 asks specifically for this distinction.
The classic profile versus policy debate. This is, fundamental NetScaler architecture.
The options are all over the place. One says profiles are for hardware and policies are for software. Another says profiles are mandatory and policies are optional. Help us cut through the noise. What is the mental model we should use here?
The correct answer, and this is one to write down, is that the profile defines the actions, while the policy defines the traffic to inspect.
Okay. Profile is actions. Policy is traffic. Can we make that more concrete?
Sure. Think of airport security. The profile is the set of rules for the screening process. Shoes off, laptops out, no water bottles.
Okay.
It's the definition of what security looks like. It lists all the checks. SQL injection check, cross-site scripting check, buffer overflow check. That's your profile.
Okay, so the profile is the rule book.
Exactly. But a rule book sitting on a shelf doesn't stop anyone. That's where the policy comes in.
Right.
The policy is the guy standing at the start of the line directing people. He says, you go to the pre-check lane. You go to the standard lane. The policy is the filter. It says, for this specific traffic coming from this URL, apply that specific profile.
That is a huge aha moment. So I could build the most robust security profile in the world, super strict, blocks everything, but it sits there doing absolutely nothing until a policy points traffic at it.
Exactly. And that separation is powerful. It means you can have one profile for your high-security banking app and a completely different, looser profile for your public marketing blog, all running on the same box. The policies act as the traffic cop, deciding which profile gets applied to which user.
I love that. Okay, speaking of security, let's talk about the things attacking us. Bots. Question 5 asks, which technique is used to distinguish between a human user and an automated bot?
A very 2025 problem.
The options include things like IP address verification, port scanning, and data compression. But the answer is client challenge, or KPTCHA.
Right. And here's why the other options fail. A lot of people want to say IP address verification. They think, well, if the IP is from a known botnet, block it.
That sounds logical.
It is logical for blocking known bad actors, but it's not a distinction technique. It's a reputation check.
Yeah.
A smart bot can route through a residential proxy. It looks like it's coming from your neighbor's house. IP verification tells you where they are, not what they are.
So you need to test the entity itself.
Exactly. You need a Turing test. A KPTCHA, or a client challenge, involves giving the client a task. Identify the crosswalks in this picture, or solve this math problem.
Right.
These are things that are trivial for a human brain, mostly, but computationally difficult or impossible for script to execute.
It forces an interaction that requires cognition.
Or at least a browser stack that mimics a human. It's the only way to reliably separate the signal from the noise when the IP addresses are spoofed. The exam wants you to know that simply blocking an IP isn't enough anymore. You need that behavioral challenge.
Now, bots are annoying, but this next threat sounds actually destructive. Question 8 introduces XML denial of service.
Yeah, this is the hidden bomb scenario.
The question asks which security check protects against malicious XML structures, like deeply nested tags or oversized payloads. And the answer is logically XML denial of service, or XML DOS. But walk us through the threat. Why is a nested tag dangerous? It sounds like bad formatting, not a weapon.
It's an exhaustion attack.
Yeah.
Imagine you send a server a box. Inside that box are 2 boxes. Inside each of those are 2 more. And it goes down like 1,000 levels.
Okay, like a Russian doll from hell.
Exactly. The server tries to unpack it to read the data. It starts opening boxes exponentially. The memory and CPU required to track all those open boxes skyrockets.
Wow.
You send a file that's maybe a few kilobytes in size, but when the server tries to parse it, it consumes gigabytes of RAM.
So the server chokes.
It freezes, it crashes. That's the denial of service. It's not about stealing credit card numbers. That would be a credit card protection check.
Yeah.
This is purely about keeping the system standing.
Right.
The exam wants you to know that XML checks protect the infrastructure resources as much as the data.
Which flows perfectly into question 10, which is also about protecting resources. This one covers rate limiting.
Fundamental control.
The question asks for the purpose of rate limiting, and one of the wrong answers is to change the web page colors, which I really hope nobody picks.
If your rate limiter is changing colors, you should call support immediately.
The correct answer is to prevent a single user from overwhelming resources.
Right. Think of it as the bouncer at the club door. It doesn't matter if you're a VIP or a regular guest. You cannot bring 5,000 friends in at once.
It's about fairness.
It's about fairness and survival. If one client, maybe a bot, maybe just a broken script, starts hitting the login page 1,000 times a second, the database behind that page will melt.
Yeah.
Rate limiting puts a ceiling on it. You get 5 requests per second. Anything else is dropped.
So it prevents a single bad actor from ruining the experience for everyone else?
Exactly. It keeps the lanes open. It creates a stable, predictable environment regardless of traffic spikes. Okay, we've done visibility, we've done security. Now I want to get into the really cool stuff. Segment 3. Advanced logic and authentication. This is where the NetScaler starts to feel less like a switch and more like a computer.
This is the logic layer. Yeah.
Question 6 brings up HTTP callouts. The question asks, why would an administrator use an HTTP callout in a policy?
This is one of the most powerful features in the toolbox.
The answer is to fetch external data for policy evaluation. But explain that to me like I'm 5. What does that actually look like in the real world?
Okay, imagine you're a security guard at a building. Someone walks up and shows you their ID. You look at the ID, that's local evaluation, but maybe the ID looks okay, but you're suspicious. So you pick up the phone and call a headquarters. Hey, is this person actually employed here? Are they on a suspended list?
And you wait for an answer before you open the gate.
Exactly. That phone call is the HTTP callout. The NetScaler pauses the traffic, sends a request to an external server, a database, a reputation service, a third-party API, gets a response, and then decides what to do based on that answer. That's incredible. So it's not limited to just the information inside the box. It can talk to the rest of the world to make a decision.
Real-time dynamic decision-making. It changes static policies into intelligent ones. You can ask an external database, is this user a premium subscriber? If the answer is yes, you send them to the fast servers. If no, the slow servers, all happening in milliseconds.
Okay, let's talk about identifying that user at the gate. Question 3 is about MFI multi-factor authentication.
Standard requirement these days. You almost can't deploy without it.
The question asks, which protocol is commonly used for the second factor? We've got options like SMTP, FTP, Telnet, but the answer is Radius.
This is a classic protocol question.
Why Radius? Why not LDP? I know LDT handles usernames and passwords.
LDP is great for that first factor talking to Active Directory. Is this password correct? Yes or no? But the second factor, that 6-digit code on your phone or the push notification, that usually lives on a separate system, a token server.
And Radius is the language that token server speaks.
Correct. Radius was built to be a carrier for authentication messages. It acts as the bridge. NetScaler talks Radius to the token provider, the provider says code accepted, and then NetScaler lets you in.
Okay.
If you see two-factor or token on this exam, your brain should immediately start looking for the word radius.
Good tip. Connect those dots. Token equals radius.
Exactly.
All right, final question of the day, question 9. This is a real nuts and bolts question about customization. You want to make your login portal look pretty? Custom logo, brand colors? The question asks, where are those customized portal themes stored?
The where is it question.
Options include kernel memory, external USB drive, or the BIOS.
Please don't put your logos in the BIOS.
The answer is the local file system.
Right, and this is about understanding computer architecture. Kernel memory is for high-speed packet processing. It's expensive, volatile real estate. You don't clog it up with JPEGs and CSS files.
Those are static assets.
Exactly. They live on the hard drive, the local file system, specifically in a directory like Varnet Scalar login themes.
Yeah.
Why? So they persist after a reboot, so you can back them up with a file transfer tool, so you can edit the HTML code.
It makes total sense. Keep the heavy lifting in the kernel, keep the decorations on the file system.
Ideally, yes. The exam tests this to ensure you aren't trying to troubleshoot a missing logo by dumping the kernel memory. You need to know where the files actually live.
Thanks for guiding us through the maze today.
Anytime. Good luck with the studies.
See you in the next deep dive.